Uh, in this afternoon session, we will learn about the definite integral, fundamental theorem of calculus, and indefinite integral. If possible, let's try to also learn about the area between curves, yeah, because all of them are related. So, the definite integral. In the morning session, we have learned about antiderivative. Now, what is definite integral? Yeah. So this is the basic definition, but this is quite hard to understand. So just take a look at this one. So basically, if f is integrable, so if we have a function f that we can integrate it, then this is the definite integral. Integral of f from a to b will look like this. Yeah. The lower limit is at the bottom and the upper limit is at the top. And here is the integral sign, and in the middle is the function that is to be integrated. We call it the integrand. And then here x is the variable of integration. For example, this is related to integrability, whether the function can be is integrable or not. Yeah, we see that we have the function f is 1 if x is rational and 0 if x is irrational. In this case, the function has no Riemann integral over 0 to 1. From 0 to 1, the function cannot be integrated. We can compute the integral like this. This integral does not exist. Why? Because between 0 and 1, the jumps can happen well, infinitely many. Yeah, it's too erratic. So sometimes it goes up, sometimes it goes down to 0, sometimes up to 1. But the interval of the jump can be very, very, very small. It's almost 0. So in this case, we cannot actually, in the Riemann integral, yeah, we cannot really make this kind of we cannot make this kind of squares, this kind of partitions. Yeah. So that's why we cannot have the integral if the function is like this. The rules for integrals are at least these 7. Yeah. So we have the order of integration. So if we flip the upper limit with the lower limit, so let's say integral from b to a fx dx is actually equal to minus integral from a to b fx dx. Pada definite integral, ya, kalau kita balik kalau posisi batasnya kita balik, yang tadinya di atas menjadi di bawah, maka tandanya berubah menjadi negatif. Then there is this zero width interval, So if the lower limit and the upper limit are the same, then the integral must be 0. Jadi kalau batas bawah dan batas atasnya sama, maka integralnya pasti 0. If we multiply by a constant, then we can take out the constant like this. And we also have sum rule, difference rule, additivity. Additivity means that, okay, if we want to integrate f of x with respect to x, we integrate it from a to b plus the integration from b to c. Then in this case, we can combine the integral since the integrand are the same. Yeah, we can combine it to be integral from a to c fx dx. Ini karena integrannya sama-sama fx, maka kita bisa menggabungkan. And then there is this max min inequality. So if we have integral from a to b fx dx, then it must be less than or equal to maximum of f times b minus a, and greater than or equal to minimum of f times b minus a. And we also have domination. For example, if on the interval from a to b, f is always greater than g, so let's say f is always on the top of g, then in this case the integral is also if we integrate them, the sign will not change. The comparative sign is still greater than or equal to. For example, suppose that we have integral from -1 to 1 fx dx is 5, and from 1 to 4 fx dx is -2, and from -1 to 1 hx dx is 7. So in this case, if we are asked to find what is the value of the integral from 4 to 1 fx dx, then we flip the limits. So we put the upper limit to bottom and the lower limit to top. So we have now minus integral from 1 to 4 fx dx. Then in this case we know that minus the integral from 1 to 4 fx dx is -2. Then we can just substitute it. Also, if we have the same interval, so if the interval are the same, so from -1 to 1, then we can do like this. Integral from -1 to 1 of 2fx plus 3hx dx. Then we can split it into 2 times integral from -1 to 1 fx dx plus 3 times integral from -1 to 1 hx dx. And then we can substitute the value. How about if we want to find the integral of fx dx from -1 to 4? Since we have the integral from -1 to 1 and from 1 to 4, then we can split the interval. We can split into -1 to 1 plus from 1 to 4. Then in this case, we have both of the integral values, which are 5 and -2. We add them together, then we have the results. Any questions?
I'm sorry, sir.
Ya.
Ini soalnya, maksudnya ini 3 integral terus jadi soal sir atau gimana ya?
Yes. So
jadi
we have three known integrals. Ya, jadi kita punya 3 integral yang kita ketahui
dalam satu soal.
Yes. And then we are asked to find the integral from 4 to 1 fx, and also integral from -1 to 1 is, and also from -1 to 4 fx.
Oh, soalnya itu yang di bawah itu, sir, yang.
Ya.
Oke, thank you, sir. Baru ngerti.
Any other question? No? Then okay. Now we are asked to show that the value of integral from 0 to 1 of square root 1 plus cosine x dx is less than or equal to square root of 2. And in this case, we can use this rule number 6, max min inequality. We take the max because what we want is always less than or equal to. Yeah, so we take maximum f times that one. So in this case, we know that the maximum over 0 from 0 to 1, the maximum of cosine of x is 1. So in this case, the maximum of square root of 1 plus cosine of x is actually square root of 2. So in this case, from rule number 6 here, we can directly compare it. Yeah, integral from 0 to 1 square root of 1 plus cos x dx is always less than or equal to square root of 2 times b minus a. Yeah, b is 1 and a is 0. So we have this. This is the answer. Yeah. Any question for this example?
I think no, sir.
And okay, now I'm talking about something a little bit different. Yeah. So here, if we talk about just the normal definite integral, the value can be negative. Jadi definite integral yang normal itu nilainya bisa negatif. But now we are talking about the area under the graph of non-negative function. So basically, if f is non-negative, then the area is basically the integral, the definite integral of f from a to b. This is the basic definition. So, for example, we want to find the area of a under y equals x over the interval from 0 to b. We can compute we can find the area from this integral. Yeah, integral from 0 to b x dx. Since we know from 0 to b x is always non-negative, then we don't need to put anything there. We can just integrate it and then compute the solution. We have that the area is b squared over 2. For this example, I want to give another illustration. So if we draw the equation, x, y, in this case we have that the equation y equals x is basically this guy. Yeah. Now what we want to find is the area b is greater than 0. Let's say we have b here. This is b. So we want to find the area from 0 to b. So the area is this guy. What is the shape of the area between the area under the line y equals to x and x-axis? In this case, apa bentuknya?
Segitiga siku-siku.
This is a triangle. Yeah. With the length b and the height also b. So in this case, we find that, let's say here is the area A. Yeah. With our knowledge from high school, we have that the area is half times the base b times the height also b. So this is b squared over 2. Yeah. You see that we have the same results from both the integration and our usual formula. Yeah. Any question? Any question?
No, sir.
Tunggu, tunggu. Mencoba memahami. Itu kan intervalnya, sir, 0, B ya, sir.
Yeah.
But why you putting the B at the X? Why? Yeah.
At the X?
Yeah,
because
itu, sir.
because the interval is the interval of X. So X goes from 0 to B in this case.
Tunggu. Berarti
Okay.
kalau tunggu, coba, sir.
Ya, interval ini pada dasarnya adalah domain dari persamaan ini, ya. Domainnya berarti adalah domain untuk X, bukan untuk Y.
Berarti kalau domainnya untuk Y, B-nya pasang di garis Y dong, sir?
Yes.
Okay.
We have to make sure that we read the problems carefully.
Oh, yeah, Y equal to X, ya. Sorry, sir. Okay, thank you.
Any other question? No?
I think no, sir.
Then, I think this is the last part of this slide, yeah. Suppose that we have a function f, and we want to compute the average value, or mean. So the average value is basically the integral of f of x from a to b with respect to x, divided by the length of integration. Jadi apa nilai rata-rata dari fungsi f dari pada interval a sampai b adalah definite integral dari a sampai b, ya, dari f dikali dengan 1 per panjang dari intervalnya. Panjang dari intervalnya adalah b minus a. So, find the average value of f of x equals square root of 4 minus x squared on minus 2 up to 2. So in this case, we know that we basically know that the area, yeah, you see that here we have the definite integral, and if f is always positive, yeah, like in this case, we know that f is always positive, then basically the integral from the integral of f over the interval is basically the area. So here we have that f of x is basically upper semicircle of radius 2. Ya, jadi di sini fx adalah setengah lingkaran dengan jari-jari 2 pada dasarnya, yang ada di sebelah atasnya sumbu x. Then we know that it is easier for us to compute the area by using this formula, ya. Lebih mudah bagi kita untuk menghitung luasnya menggunakan rumus luas lingkaran. And since we want to compute the area of upper semicircle of radius 2, then we just need to divide the area pi times r squared by 2. Then in this case we have that the area is basically 2 pi. Ya. Luas setengah lingkarannya untuk kasus ini adalah 2pi. Therefore, the average value is basically 1 over 2 minus 2 times the area, which is 2 pi. Then in this case, we have pi over 2. Yeah. For this example, any question? Then let's compute this. Express the following limit definite integral. So this guy, this is easy, yeah. Why? If as you've heard this morning, that basically our integral is derived from Riemann sum. Here we have Riemann sum, and the partition is from 0 to 2. Then in this case, this sum, if the limit of the length of the partition is going to 0, this is basically equal to integral from 0 to 2 of x squared dx. This is the answer. Ya. Jadi di sini kalau kalian lihat ini adalah bentuk Riemann sum, ya. Kemudian kita buat delta x-nya ini semakin dekat dengan 0. Maka bentuknya ini karena intervalnya adalah dari 0 sampai 2 dan fungsinya adalah ck kuadrat, maka kita punya dia sama dengan integral dari 0 sampai 2 x kuadrat dx. Any question?
So, sir, itu berarti cuma sependek itu nggak ada kita ngitung berapa deltanya, berapa k-nya gitu?
Yes.
Oke. Tapi ini berlaku buat seperti ini, bentukan seperti ini, Riemann apa?
For the sum here, is it clear? Any question?
Ya, sir, clear. Tadi pertanyaannya sama kayak Raisel. Udah.
Okay, now this one. Suppose that f and g are integrable and that the value of the integral, we have all of this here. So find the first one. A, yeah. Integral from 2 to 2 gx dx. What is it? Integral from 2 to 2 gx dx. So the lower limit is 2, the upper limit is also 2, then in this case the integral is 0. Now for B, integral from 5 to 1 gx dx is actually minus integral from 1 to 5 gx dx, so minus of 8, because what we have here is integral gx dx from 1 to 5, so we just need to flip the limits. For C, integral from 1 to 2 3 fx dx. In this case, we take out the constant, so we have 3 times integral from 1 to 2 fx dx, which is equal to 3 times minus 4, which is equal to minus 12. For D, integral from 2 to 5 fx dx is basically integral from 1 to 5 fx dx minus integral from 1 to 2 fx dx. So in this case, we have that the value is 6 minus 4, which is 10. And for E, we have that integral from 1 to 5 of f of x minus g of x dx is equal to integral 1 to 5 f of x dx minus integral 1 to 5 g of x dx, which is 6 minus 8, which is minus 2. So for f 1 to 5, 4 fx minus gx dx is equal to 4 times 6 minus 8, which is
2.
No, 24 minus x, yeah, 16.
16.
Yeah. Any question for this example? Is it clear?
Sir,
Easy enough.
can I see
Yeah.
the E? Oh,
Yeah.
ya. Tadi saya salah, harusnya 6, dikurang 8, saya 8 kurang 6. Right, it's
Okay, any other question? No?
I think no, sir. Clear.
Graph the integrands and use known area formulas to evaluate the integrals. So if we graph it, this guy, since we want to compute from minus 4 to 0, it is basically x, y. So we have this a quarter of a circle with the radius 4. Yeah. So so in this case, integral from minus 4 to 0 of square root of 16 minus x squared dx is basically 1 over 4 times the area of circle, yeah, pi times 4 squared. So we have 4 pi. Is it clear?
Sir, I'm sorry.
Yeah.
I just curious, where do we get the pi?
Where do we get the pi? Pi here, okay. The area of a circle, yeah. Area of a circle is A equals to pi r squared.
Mm-hmm.
So for this integral, the actual trick is, okay, this is not, I mean, this will be, I think this will be learned after the midterm.
Mm-hmm.
But okay, so basically we let x to be equal to 4 cosine of theta. Then in this case we have that x equal to -4. We have theta equals to pi, and if x equals to 0, theta equals to pi over 2. So here we have that integral, sorry, not yet. We have that dx now is equal to -4 sine theta d theta. So here the integral from -4 to 0, square root of 16 minus x squared dx is basically integral from pi over 2 to pi square root of 16 times 1 minus cosine squared theta. Dx is now becoming times -4 sine theta d theta. So here, if we flip the integral, if we flip the limit, then we have integral from, oh no, this is not from pi over 2 to pi. So this is from pi to pi over 2. I'm sorry. From pi to pi over 2. Yeah. So here we flip the limit from pi over 2 to pi. Then we have square root of 16 times 1 minus cosine square x is basically 4 times sine x. Sorry, 4 times sine theta. And then since we multiply again by 4 times sine theta, we have that now this is not 4. Sorry, we have 4 squared sine squared theta d theta, and the negative is gone because we flip the limits. And from this you can continue to compute. From this you can continue, but this idea of substituting with trigonometric function, we will learn about this after midterm, I believe. Yeah. Now, graph the function and find its average value over the given interval. So if we graph it, we will get a picture like this. Minus absolute x. So here is this guy. Minus 1, 1. Let's call it area A and B, yeah. Integral of A and B. Okay, so for A, we have that integral. Sorry. For A, the average of h is actually 1 over 0 minus 1 times the integral from -1 to 0 of x dx. So we have here 1 over 1. Then in this case we have that x over 2 squared, x squared over 2 from -1 to 0. So here we have that minus half. For B, we have that average of h is now 1 over 1 minus 0 times integral from 0 to 1. And for the area B is basically minus of x, yeah? Minus x dx. So in this case we have minus of x squared over 2 from 0 to 1, which is minus half. And for C, the average h is basically 1 over 1 minus 1 times integral from -1 to 1 of absolute value of x, minus absolute value of x dx, which here we have half times integral from -1 to 0 of x dx, and then minus integral from 0 to 1 minus x, not minus x anymore, plus and minus x dx. And if you compute this, you will actually get also minus half. Yeah, any question?
Sir,
Yeah.
balik ke share screen, sir. Yang sir ada gambar itu loh, grafiknya.
Ya.
Itu kalau itu kan sir gambar apa ya? Itu min 1 sama 1 ya itu.
Let me make it.
Min 1 min 1 min 1.
And this line is h of x equals to minus absolute value of x.
Oh wait, di mana ya? Min 1 bukan, sir itu maksudnya sir gambar buat apa, sir?
No, because I draw the picture because in the question we are asked to graph the function.
Graph the function. Berarti maksudnya function A, B, C atau cuma yang function ini, sir?
The function over the given interval. So basically we have the interval from -1 to 0, 0 to 1, and from -1 to 1. So I can just combine them here.
Okay. I got it.
You see here that we have interval from -1 to 0, also from 0 to 1, Of course, we also have interval from -1 to 1.
Oh, so sir cuma bikin dari -1 to 1 ya?
Yeah.
Oke, thank you sir.
Any other question? No. Then that's all for the definite integral. Now I want to talk about the most important topics in calculus that is called the fundamental theorem of calculus. So the fundamental theorem of calculus part 1 says that, okay, if we have f of x, capital F of x is integral from a to x of f of t dt, small f of t dt, then the derivative is basically just small f of x. Yeah. So for example, we know that y is from a to x, integral from a to x of 3 power 3 plus 1 dt. Then in this case, we have that dy dx is basically x power 3. Yeah. We just change t into x plus 1. And for b, here we have that the interval is flipped. Yeah. The interval is from x to 5. Since we have the fundamental theorem of calculus, x is placed on the upper limits. Then in this case, we have that we need to flip the interval first, so that x is now in the upper limit. Then we apply the fundamental theorem of calculus. Then in this case, we get that dy dx is actually minus 3x sine x. And what happened if we have now instead of a to x, we have a to x squared. We have 1 to x squared here. Then in this case, we can use the chain rule. Yeah. How to use the chain rule? It's the same. We let u equals to x squared. So we differentiate with respect to u first, and then we differentiate x squared with respect to x. Jadi di sini kalau kita sekarang batas atasnya bukan lagi x, tapi batas atasnya adalah x kuadrat, maka kita bisa pakai aturan rantai. Seperti ini. The same thing happens with d. In the question D here, we need to flip the integration limits first, and then we apply the chain rule again. Any question? No?
No. Yeah. Okay, no.
And we have the second fundamental theorem of calculus. It says that basically, if we have, this is what you already know. Yeah. If f is an antiderivative of f, then definite integral from a to b, small fx dx is basically capital F at b minus capital F at a. Yeah. This one you already know. For example, okay, since we know that the antiderivative of cosine of x is sine of x, in this case we have that integral from 0 to pi cosine of x dx is basically sine of x. We evaluate from 0 to pi, and we put sine of pi minus sine of 0. Also with secant x, tangent x, we know that the integral is secant of x. Then we just put the interval like that. Yeah. For this example, any question? No?
Oh, sir, maybe just go to sample. Ini masih teori kan, sir, atau?
Ya.
Ini masih contoh apa? Apa sih namanya? Lebih apa, sir? Lebih butuh ke contoh soal sih, sir. Yang langsung soal cerita gitu, sir.
Yeah, this is the example, okay? We consider a heavy rock blown straight up from the ground by a dynamite blast. Ya, jadi kita punya batu yang diledakkan ke atas, ya, dengan ledakan. Jadi batunya meledak ke atas. And the velocity of the rock at any time t during its motion is given as Vt equals to 160 minus 32t feet per second. Ya. Dan di sini kita tahu kecepatannya. The question is find the displacement of the rock during the time period from 0 to 8. For A, the displacement is basically the definite integral of Vt dt. Jadi kita diminta seberapa jauh batunya berpindah. Maksudnya jarak dari posisi batu pada pada detik ke-8 dibandingkan posisi batu pada detik ke-0 berapa, kita cukup menggunakan integral tentu saja, ya, integral definite. Then we have that the distance, the displacement is actually 256 feet. Yeah. As for B, this is quite different. Yeah. For B, we want to find the total distance traveled during this time period. Okay. If we want to find the total distance traveled, in this case, we have to make sure we compute all kind of we have to make sure that all the value of v is positive, but here we have that v is positive over the time interval from 0 to 5 and negative from 5 to 8. So in this case, the total distance traveled is basically, we take also definite integral, but now we take the absolute value. Yeah. Now we take the absolute value, and the integral becomes like this. Integral from 0 to 5 absolute value of v dt plus integral of 5 to 8 absolute value of v dt. And we have that vt is positive, yeah, so the sign does not change from 0 to 5, and negative from 5 to 8, so the sign we change it from positive to negative. Jadi di sini karena v-nya positif di 0 sampai 5 dan negatif di 5 sampai 8, maka dalam hal ini, ya, kita ambil nilai absolutnya, ya, tetap definite integral, tapi kita ambil nilai absolutnya dari 0 sampai 8, tapi kita ambil absolut dari kecepatannya. Kemudian kita split intervalnya, yang mana yang positif, yang mana yang negatif. Kemudian setelah itu kita masukkan, ya, karena 0 sampai 5 v-nya positif, dia tidak berubah tanda. 5 sampai 8 v-nya negatif, maka tandanya berubah menjadi negatif. Then we simply need to finish the definite integral after that. Any question? Any question?
Sir, itu yang IB, sir, yang dalam kurung 160T kurang 16T kuadrat. Itu dia pakai T-nya sama dengan 5, terus yang di sebelah kanan T-nya sama dengan 8 ya, sir? Atau gimana?
Which one? This for A or for B? The answer for A or
B,
the answer for B?
B.
For B.
Ya, itu T-nya disubstitusi jadi berapa, sir? Soalnya
Yeah,
di bawah
okay. The first part, we substitute from 0 to 5, and the second part, we substitute from 5 to 8. Yeah, even though they are the same, we have the negative here. Meskipun mereka sama, intervalnya berbeda, ya, tapi dan juga kita punya tandanya sekarang di sini negatif. Ya. Any question?
Wait, sir. Masih belum ngerti, sir.
Karena kita mau menghitung total jarak yang ditempuh. Batunya ditembak ke atas, berarti kan dia nanti naik ke atas, suatu saat berhenti turun ke bawah.
Turun ke bawah.
Ya. Nah, kita tidak tahu apakah dari 0 sampai 8 detik itu dia naik terus atau sudah turun lagi. Di pertanyaan A, kita tidak mempedulikan apakah dia sudah turun lagi atau tidak, ya. Karena kita mau hanya mencari jarak dari posisi dia sekarang dibanding posisi dia di awal. Sehingga kita cukup pakai definite integral ini. Untuk yang B, itu kita memperhitungkan yang naik ditambah yang turun berapa. Makanya kita mengambil sekarang nilai absolutnya dari kecepatan. Karena kecepatan positif itu naik, kecepatan negatif itu turun. Nah, di interval 0 sampai 8, kita tahu bahwa dari 0 sampai 5 dia naik positif, ya. Dari 5 sampai 8 dia turun negatif. Maka menghitungnya seperti ini.
Oke, sir. So my question is, sir, yang B itu, sir. Nah, kan udah di yang 160T kurang 16T kuadrat itu, sir. Contoh yang itu ya, sir. Itu kan, sir, dapat 400 kurang minus 144. Nah, maksud saya, sir, 400-nya itu kalau, sir, substitusi T-nya jadi berapa?
The 400 is for this interval. From 0 to 5 is 400. 400 itu dari 0 sampai 5, ya. Kalau kita masukkan T-nya 5, kita punya 160 kali 5 min 16 kali 25, ya, yaitu 400. Kemudian kalau kita masukkan 0, 160 kali 0 min 16 kali 0 tetap 0, ya, jadi 400.
Oh, kalau yang sebelah kanan berarti
minus 144, we substitute 8 and 5.
And 5. Oh, iya. Okay, thank you, sir.
Any other question? No? Then this is another example. Yeah. Consider the function f of x squared minus 4, and its reflection across x-axis, which is 4 minus x squared. Kita punya fx dan gx, ya, di mana gx adalah cerminan dari fx terhadap sumbu x. Then for each function, yeah, for f and for g, we are asked to compute the definite integral over the interval from minus 2 to 2 and the area between graph and the x-axis. So, if we just need to compute the definite integral, then we simply compute it like this, ya. Kalau kita cuman diminta untuk mencari integral tertentunya, maka kita cukup melakukan integral yang seperti ini, ya, dari minus 2 sampai 2 fx, dari minus 2 sampai 2 gx, dan seterusnya. Then in this case we have that the definite integral of f of x from minus 2 to 2 is minus 32 over 3, and while the gx is 32 over 3. Ya. Ini this is normal. Why? Because gx is the reflection of f of x across x-axis. Ya. Ini normal karena gx adalah cerminan dari fx di terhadap x-axis. Ya. Sehingga integralnya mereka sama, cuman beda tanda saja. Karena satunya ada di atasnya x-axis, satunya ada di bawah x-axis. Then what about the area? The area, if you want to compute the area, you need to take the absolute value. Karena mau mencari luas, ya, luas antara grafik dengan sumbu x, maka kita mengambil nilai absolutnya. So in this case we have that the area is positive 32 over 3. Ya. Jadi from here we know that if we are asked the definite integral, the sign could be negative or positive. And if we are asked about the area, then the sign must be positive. Ya, kalau kita diminta untuk mencari integral tertentunya, tandanya bisa positif, bisa negatif. Tapi kalau kita diminta untuk mencari luas daerah, ya, antara grafik dengan sumbu x, maka kita ambil nilai mutlaknya. Okay, wait a moment, okay? Yeah, any question? Any question? No? Is it clear for this example?
Yeah, clear, sir. Very clear.
I think it's clear, sir.
Okay. This is another example. Yeah. We have the function f of x equals sine x from x0 to x 2 pi. Then if we are asked to compute the definite integral, we simply need to compute the definite integral like this, which results in the value 0. But if we are asked to compute the area between the graph, again, we take the absolute value, for which in this case, we need to split the intervals. Why? Because from 0 to pi, the value of sine of x is positive. And from pi to 2 pi, the value of sine of x is negative. Kita tahu bahwa fungsi sinus itu kan naik, turun, naik lagi. Ya. Dan dari 0 sampai pi, fungsi sin x itu selalu ada di atas sumbu x. Selalu positif. Dan dari pi sampai 2pi, dia selalu negatif. Ya. Karena di sini kita diminta untuk mencari area, maka kita menggunakan mutlaknya. And in this case, we have that the area is 4. Yeah. For this example, is it clear? Any question?
No, sir.
The other? No?
I think no. Clear, sir. I think it's clear.
Okay. This is the for this one. Let's just do it together. Here we are asked to find the area between the x-axis and the function f of x equals x power 3 minus x squared minus 2x. So here we have that f of x equals x power 3 minus x squared minus 2x, which is equal to x times x squared minus x minus 2, which is equal to x times x minus 2 x plus 1. Okay. So here we have that if this is equal to 0, then we have x to be equal to 0 or x equal to 2 or x equal to minus 1. So now we know here from x from minus 1 to 0, we know that f of x is from minus 1 to 0 is positive or negative. From minus 1 to 0. Let's say we put x. Okay. x also from 0 to 2, f of x is, if we put 1 minus 1, 0 minus 2, it's negative, yeah. F of x is negative. So I think that this guy is positive. So if we want to find the area, then we need to integrate from -1 to 2 of absolute value of f of x dx, which in this case we have integral from -1 to 0 of absolute value of f of x dx plus integral from 0 to 2 absolute value of f of x dx, which in this case we have integral from -1 to 0 of since between -1 to 0 the value of f is positive, so we don't change the sign. X power 3 minus x squared minus 2x dx, and then since between 0 to 2 the value of the function is negative, we take the negative minus integral from 0 to 2 x power 3 minus x squared minus 2x dx. So we have x power 4 over 4 minus x power 3 over 3 minus x squared from -1 to 0 minus x power 4 over 4 minus x power 3 over 3 minus x squared from 0 to 2. So here we have from -1 to 0, so we put minus 1 over 4 plus 1 over 3 minus 1. 3 over 1 over 4 minus 1 over 4 plus 1 over 3. So here we have minus of 1 over 4 plus 1 over 3 minus 1. Then we minus 2 power 4 is 16 over 4 minus 8 over 3 minus 4. So we have minus 17 over 4 minus 9 over 3. Sorry, minus and plus. So this is not 9 over 3, but 7 over 3. And minus 1, plus 1 plus 4 plus 5. Yeah. So here we have, okay, over 12 minus 17 times 3 is 51. Minus 7 times 4 is 28. Plus 5 times 12 is 60. So here we have minus 19 over 12. No, this is not correct. This is not correct. We put 0 and we put -1. Something is wrong. Value should be positive. Can anyone spot the mistake that I make? -1 to 2, we split into -1 to 0. Why? Because the value from -1 to 0, let's say, let's just test it. So f of -half is actually -half cube minus half squared minus 2 times -half. Here we have -1/8 -1/4 plus 1, which is 2/8, 3/8. 1 minus 3/8, so it's 7/8. So this is positive. So the other part should be negative. Then we have that the integral from -1 to 0, the sign is good. And from 0 to 2, the sign is now negative. So we have that the integral is okay. I think the integrals are correct. Now, if we put 0, everything here 0, minus, if we put -1, minus 1/4, then minus 1/3, so plus 1/3, minus 1. So this guy is equal to 1 minus 1/4 minus 1/3 is equal to 12 minus 3 minus 4/12, which is equal to 12 minus 7, 5/12. So there should be no more minus. So here we have 5/12, and for the next one is, this is equal to 16. Okay, 2 power 4 is 16/4 minus 2 power 3 is 8/3 minus 2 squared, so minus 4. So we have 4 minus 8/3 minus 4, which is minus 8/3. Or this is equal to minus 32/12. So in this case, indeed I made a mistake in the calculation. It should be minus 32/12. So here we have 37/12. Yeah, positive. Yeah, this is correct. Yeah. Any question for this example? Ada pertanyaan?
Sir, bisa ke bawah dikit? Oke, can I read? 16. 32 minus. Okay, thank you, sir.
Yeah. Any question? No? If not, then let's jump to indefinite integrals and the substitution method. Yeah. This is the last part of our class today. Yeah. So we just need to learn from examples in this case. Yeah. First one, we want to find the integral of x power 3 plus x, and we take the power 5 times 3x squared plus 1 with respect to x. In this case, if we set u to be equal to x power 3 plus x, then we know that du is basically du dx, yeah, times dx, which is 3x squared plus 1 dx. So if we substitute them, then we know that x power 3 plus x is u, 3x squared plus 1 dx is du. Then here the integral becomes now very simple. Yeah, it becomes u power 5 du, the integral of u power 5 du. Then we just need to integrate them, integrate it. Yeah, we get u power 6 over 6 plus c. Then we substitute back u equals to x power 3 plus x to the final result. So we get the integral of x power 3 minus x, x power 3 plus x power by 5 multiplied by 3x squared plus 1 dx is actually x power 3 plus x we powered by 6 divided by 6 plus some constant. For this example, is it clear? Any question?
No, sir.
No?
Clear.
And now for this one, yeah. This one we set u equals 5x plus 1. So du is 5 dx. So now here we have the integration becomes integral of secant squared of u with respect to u. We know that the integral of secant squared is tangent. So we have that the integral is tangent u plus c, and it becomes tangent of 5x plus 1 plus c. It's the same thing as before. We just need to substitute whatever inside. I mean, we need to choose what is the best substitution. In this case, the best substitution is we substitute u to be equal to 5x plus 1. For this one, we substitute u to be x power 3 because we have that du is 3x squared dx, so that x squared dx is equal to du over 3, yeah, 1/3 of du. So now the integral becomes the integral of e power u over 3 du. That integral of e power u is still e power u. Then in this case, we have that the integral is e power x power 3 over 3. Is it clear for this one? So basically the idea is the same, yeah. The idea is always we choose the appropriate substitution, ya. Jadi kita memilih substitusi apa yang paling tepat. That's it. If we want to integrate something. As for this one is a little bit different, yeah. since we have on the outside of the square root we don't have this 2dx, so we can change the terms. So for this case, we let u to be equal to 2x plus 1, then du is 2dx, which in this case dx is du over 2. Dx is du over 2, and x is actually u minus 1 over 2. From this substitution, we can get x equal to u minus 1 over 2. So the integral of x square root of 2x plus 1 dx can be made into integral of u minus 1 over 2. U minus 1 over 2 is the x times square root of u du over 2. In this case, we see that we have this kind of integration. 1 over 4 integral 1 over 4 integral u power 3 over 2 minus u power half with respect to u, which is much easier to be integrated in this case. Then we can simply integrate it with respect to u. And finally, we substitute u equals to 2x plus 1 back to the results. For this example, any question? Any question? Is it clear?
Wait, sir. Iya, bilang clear, tapi itu dapat dari mana ya?
Which one?
Wait, sir. 3 birds. Okay. Ya. Oke, never mind, sir. Nanti kalau bingung tanya di PC aja, sir.
No, well, can you let me know which part that is not clear yet?
Itu, sir, yang habis substitusi itu, sir. Itu kan dia x-nya itu kan jadi u ya.
X becomes u minus 1 over 2.
Over 2 ya.
And square root of 2x plus 1 becomes square root of u, and dx becomes du over 2.
Ya, it's clear, sir. It's clear. Cuma agak bingung tadi pas x-nya hilang di substitusi, baru ingat kan ditukar.
For the others? Is it clear?
I'll make this, sir.
This is the next example. Well, basically what we are learning here is the tricks to find the integration. So if we find sine squared or cosine squared, sine squared, we change it into 1 plus cosine 2x over 2, for which we have the derivative in this case. Okay. We have cosine kx.
I don't like it.
Yeah.
I don't like it. Oh, let's look at A.
Sorry, there's a distraction a little bit. Okay, so if we want to integrate sine squared x, then we change it into 1 minus cosine 2x over 2, because we have the integral of cosine kx. Here, you just need to look at this table. What is the integral? Then you can integrate it like this. Also with cosine squared x, we change it into 1 plus cosine 2x over 2, But for the tangent of x, we change it into sine x over cosine x. And we have that sine x is basically, sine x dx is basically minus of d cos x. So now we integrate with respect to cos x. Well, you can say that here we let u equals sine x, u equals cosine of x. Di sini kita misalkan u adalah cosinus x, ya. Then we have the integral now becomes integral of minus 1 over u du. So the integral is minus ln absolute value of cos x. Jadi kalau punya trigonometri kuadrat, karena di tabel yang kita punya di sini kita tidak punya untuk sinus dan cosinus, kita tidak punya integral dari kuadrat, ya, dari bentuk kuadratnya, maka kita ubah menjadi bentuk seperti ini, ya. Jadi kalau bisa kuadratnya hilang gitu, ya. Pangkatnya harus hilang. Gimana caranya? Ya kita ubah seperti itu, baru kita integralkan. Kalau tangen x kita ubah menjadi sin x per cos x. Kemudian kita misalkan u sama dengan cos x, maka du sama dengan minus dx. Minus sin x dx. Maka kita punya integralnya menjadi integral minus 1 per u du, yaitu minus nilai mutlak u plus c. Any question? I think you have learned about this trick, this technique of integration during your high school, right? Cara integral seperti ini di sekolah sudah pernah kan ya, di SMA?
Yeah, but not this far, sir.
Are you sure?
Yeah, I'm quite sure. But soalnya waktu di high school lebih ke fungsi sih yang banyak.
But no trigonometric integral.
Ada cuma sebentar gitu, sir.
Okay. Well, maybe the curriculum is now reduced, so it must be easier for you. And now you know this trick, right? So for this example, is it clear?
Yeah, after you explain it more clearer, sir.
So the idea is if you find a question about integral, what you do is always try to find this kind of form, yeah, either x power n or sine kx or cosine kx secant squared kx, cosecant squared kx, or secant kx tangent kx, or cosecant kx cotangent kx, or e power kx, or 1 over x, or the rest, yeah. So always try to find this kind of form so that you can directly look at the table and you can immediately finish your integration, ya. Jadi kalau kalian punya masalah dengan integral, kalian punya kasus yang harus kalian selesaikan di mana itu adalah pengintegralan, maka selalu usahakan mengubah menjadi bentuk yang ada di tabel ini. Karena kalau sudah ada di tabel ini, maka kalian tinggal pakai integralnya seperti ini, ya. Ini integralnya. Yang general antiderivatif is the integral. Kalian dapat integralnya, tinggal pakai saja, gitu ya. Makanya kenapa di trigonometri yang kuadrat atau yang pangkat lebih dari itu, ya, pangkat 3, pangkat 4, pangkat 5 dan seterusnya juga, kita selalu coba ubah sampai pangkatnya habis. Sampai pangkatnya jadi pangkat 1. Sehingga kita bisa terapkan ini, ya. Any question? No?
No, sir.
This is the next example. In this one, we try to substitute u with e power x. Yeah. So we have integral of dx over e power x plus e power minus x. We change it into e power x dx over e power 2x plus 1. Kita ubah menjadi bentuk ini, ya. How we multiply both sides, both numerator and denominator by e power x. Kita kalikan pembilang dan penyebut dengan e pangkat x, maka kita dapat bentuk ini, ya, e pangkat x dx per e kuadrat x plus 1. Then we let u to be e power x, ya. Kemudian kita misalkan u adalah e pangkat x. Then we have now the integral become like this, ya. Integral of du over u squared plus 1. Sekarang integralnya menjadi seperti ini. Integral du per u kuadrat plus 1. Ya. Why? Because if u is equal to e power x, then du is e power x dx. And e power x dx is du. So we have integral du over u squared plus 1. Then after that, again, look at this table. Find this kind of form. Yeah. So the form is 1 over 1 plus k squared x squared. The integral is 1 over k tangent inverse kx. So the integral is now you see the sign is plus, yeah. So we have that the k is 1. Jadi k-nya 1 di sini karena tanda yang ada x kuadratnya ada di situ. Then we know that the integral is tangent inverse of u plus c. Now we substitute back u to be equals to e power x. And for the integral of secant of x dx, we use different tricks. Yeah. Now we multiply by secant x over secant x plus tangent of x. So we get this. And we let u to be equal to secant x plus tangent x. Yeah. So that we have that du is secant squared x plus secant x tangent x dx. Di sini kita pakai trik yang sedikit berbeda, ya. Jadi di sini kita kalikan dengan secant x plus tangen x per secant x plus tangen x, ya, karena secant x plus tangen x per secant x plus tangen x adalah 1. Kemudian kita dapatkan bahwa ternyata penyebutnya, ya, pembilangnya adalah turunan dari penyebut. Maka kita bisa misalkan u adalah secant x plus tangen x, maka turunannya du adalah secant kuadrat x plus secant x tangen x dx. Sehingga kita punya integralnya menjadi sesimpel ini, ya. Sekarang integralnya adalah integral du per u. For this example, any question? Any question? Is it clear? Is it clear for this example? I hope so. Yeah.
Harus di klon.
Harus di apa?
Klon nih. Harus klon gitu.
Okay. You can read it again later, yeah, by hand. Yeah, also try to find the integral by hand. Now let's try this one. So in this case, we let u to be equals to z squared plus 1. Then we have that du is equal to 2z dc. Yeah. Then the integral of 2z dc over root of 3 root z squared plus 1 is becoming like this, integral of du over this. So we have now integral of u power minus 1 over 3 du, which is 3 over 2 u power 2 power not 3 over 2. Oh yeah, that's correct. 3 over 2 power u sorry, times u power 2 over 3 d, sorry, not du, okay, plus c, yeah. Then we substitute back. We have 3 over 2 times z squared plus 1 power 2 over 3 plus c. Yeah, is it clear? Now let's go tackle some example.
I'm sorry, sir.
Yeah.
Can you move to? Yeah. Okay. I'm sorry, sir. Z dan Z itu stand for what ya, sir? Itu kan integral to Z dz. Nah, itu maksudnya apa, sir? Z dz.
Okay, you can see it like this. This is equal to integral of 2z over square root 3 z squared plus 1 dz, like this.
So
integral
okay.
of f of c dz. Ya.
Oh, I'm sorry, sir. Soalnya digabung jadi kayak 2z dz. Okay, thank you, sir.
Yeah. Okay, let's take a look at this. This one is easy, you can do it by yourself. Let's just tackle some hard question. I think this one.
It's so full. It's so full.
In this case, we have that. Okay, so that it is clear for you, I will rewrite this integral. Yeah, this is equal to integral of 1 over x times 1 over ln x dx. Yeah, and we let u to be equals to ln x. Yeah, you can close it. We let u equals ln x, then du. Take it. Over there. Near the door. Yeah, in front of you. I'm sorry, there is a distraction. Okay, so here du is equal to 1 over x dx. Yeah. So in this case, the integral of dx over x ln x is becoming integral of du. integral of du over u, yeah, which here the integration becomes ln of absolute value of u plus c. Now we have ln of absolute value of ln x plus c. Is it clear? For this example?
Yeah, it's clear, sir.
Okay, if so the time is up. Let me ask you one last time. Any question?
Sir.
Ya.
Kan itu asalnya mutlak X ya. Nah, kok jadi ln X itu dari yang apa pangkat sebelumnya yang dx per X ln X bukan? Atau
No.
gimana?
You see here, we let u to be equal to ln X. So here ln u, yeah. This part is equal to ln X.
Oh, that is u. I thought it was X.
Yeah, I think you will often misread my u with X.
Yeah,
because
I think
some mathematics teacher write X like this. Write X like this, right?
Yeah, yes, sir.
But that's not my style.
Yeah, I always keganti aja X sama U.
Yeah.
And I think I need the new glasses.
I'm sorry.
Oh, it's okay, sir.
Any other question? No?
No, sir.
If not, then let me end this session. But please remain in the class after I end this session because I want to talk about the next quiz next week. Yeah. Okay, let me end this session. See you next week. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Nice weekend.
So much, sir.
Thank you, sir.
Have a nice